On this very simple device tracking demonstration, we are using a server having an address of 2001 DB8 cafe : 80 connected to a switch where a normal host, which will be the victim, is connected as well as the villain. In order to prevent IPv6 address stealing by fooling with neighbor citation and neighbor advertisement, on the switch we will configure device tracking. So what we have done here, we have defined a policy called node, where device is node, is basically the one sending the NS and the NA. We are inspecting protocol DHCP v6 and protocol NDP. And by the way, we could have also done the same thing for DHCP v4. We do data cleaning, so basically we grab the context and the mapping between the v6 and the MAC address by using NDP in case we don't have any binding. We limit the address count per interface and MAC address to 10. And what we do is tracking enable reachable lifetime 300 is to say that after 300 seconds, we check and send a new NA to see whether the device is still alive. And the security level is inspect, meaning not only we are cleaning the binding, but we are also enforcing this. Having done this, we still need to apply on VLAN 1, all the ports, the tracking policy being node. Until now, there is no attack, so all the bindings will be correct. And if you look about the database, it's shown empty because we have seen no yet neighbor citation and neighbor advertisement for any traffic. So let's move to the host and see what's happening there. So we're on the host and we can have a look and try to make a ping to the server. And it's only basically to fill the cache. So if you do show IPv6 neighbor, we indeed see that for our target, which was ending by : 8, we have this kind of link local address. So now back on the switch one, and we can have now a look at the device tracking database, which contains obviously entries for both the sender of the ping, which was called babe, and of course the target of the ping, which was : 80. And we see that the source of the information is marked as ND. Obviously there has been as well as some neighbor solicitation and neighbor advertisement for link local addresses. So now let's move to VLAN and configure the wrong address. So basically we try to spoof the server. So what we have done here is basically configuring a MAC address which is easily recognizable with a bed. We disable that, which is a duplicate address detection, else the router will refuse obviously configure an address which already exists. And the address that we configure is the one ending by : 80, so the address of the server. And what we need to do is as well now to do some debug of IPv6 enabled discovery. So let's go back to host. And what we will do is first to clear the IPv6 cache of all neighbors. So basically we are losing all the mapping. So if we check it, indeed we are empty. And the goal is basically when we do a new ping, as we don't have the mapping, we will be sending a neighbor solicitation through the switch to all our neighbors. And we see it's working. And if we go to the villain, we see that he has received a couple of neighbor discovery, and we receive neighbor solicitation from this guy, and we send a neighbor advertisement back to this guy by using our spoofed source address. So, but what's happening there? For this, we need to go to the switch, and on the switch, we can have a look again at the mapping table and the binding table. And we see we still have, for the address ending by : 80, the real one. The only bad MAC address entry we have is of course for the link local. Nobody has claimed this link local of FE80 bad, so it's valid and the bad guy can insert its MAC address for an unused link local address. So back now in the host, if we look about the neighbor table, we see indeed that for the : 80, This is a good one, even if the villain has tried to send us enable advertisement just wrong, it was blocked by the switch. In short, device tracking and inspection as a policy works fine on iOS routers.